Hello. Uh, Hello, am I audible? Hello.
Yes, sir.
Okay. All are joined or what? How much time? I mean, they will take to join us. Okay, shall we start? Hello. Please reply me.
Yes, sir.
Yes, sir.
Okay. Not joining us. Okay. Shall we start or what? Or we have to wait for 11 members are here now.
Start, sir.
Okay. Okay, thank you. Uh, let me share a screen now. So everyone put your attendance in the chat box. Okay. Our first experiment is Newton's rings. Okay, Newton's rings. I think for you all, interference chapter is finished, right?
Yes,
Hello.
sir.
Okay. Now let us begin with those discussions. Uh, the basics of interference and all those things. Okay. So kindly one by one comment on what is interference. What are the types of interference? What are the conditions for interference? Just kindly go through it, please. Hello. Hello.
Yes, sir.
Okay. Newton's ring is based on a phenomena interference. अरे क्या हुआ? 1 minute. Okay, it is based on a phenomenon interference. So what do you mean by interference here? What is interference?
So the combination of two or more waves.
Combination of two or more waves. Very good. Or anyone else, please? Hello. Kindly respond, please, because I mean it should be interactive. Okay, lab करना और खत्म करना ये तो 5 मिनट का काम है. Everyone, please. What is interference?
So it is the it is the combination of two or more waves which like
Huh?
combine for a one wave and like propagate or stop.
Okay. So everyone telling that it's a mixing of two waves, right? Two waves. Okay, now I mean let us talk in terms of light itself. Okay, आपके पास दो bulbs हैं. One is LED. Okay, another one is anything tube light. Okay, both of them now on. Okay, in a room. Whether these two, I mean, lights coming out from these two sources are undergoing interference. I mean, if anyone having a mic issue, then you can use chat box. Okay, but everyone has to respond.
Sir, can you
Okay,
repeat what you said?
yes, we have two sources of light. One is LED bulb is there. Another one is tube light. Both are emitting light. Okay, whether these two, I mean, the waves coming out from these two sources are undergoing uh, interference.
No, sir.
So no, no interference. Anything else? Anyone else? I mean, who says yes?
So for interference, the source of light should be monochromatic. So if you take two
Yeah,
different sources, so it will not show interference.
yeah, condition is there. Okay, the first condition, as uh, as told by I'm sorry, मुझे नाम पता नहीं चला, आपका नाम बता दो प्लीज.
Amaya,
Amaya, very good, Amay. So the sources should be monochromatic. Okay, any other condition? So I have two laser. Okay, now I'll modify these two into two laser sources. Okay, two red lights. Then it will undergo interference.
so if they have the same frequency and amplitude, then I guess they can undergo interference.
If they have same frequency and amplitude.
Amplitude.
Yeah. Same frequency means it's monochromatic. Same amplitude. Okay, then
So
anything
same
else?
direction.
That is the, I mean, same direction uh, is the, I mean, property of laser. It is actually. Okay, let me write direction then.
Sir, sir, I joined late. Can you just give me the summary
Condition
of
for interference. Condition for interference. What is interference? Question is what
So
is
they
interference?
must, so they must have same or equal phase differences.
Okay. Yeah, here is the point comes here. The phase difference.
And they must be coherent waves.
Yeah,
It's
the
the same
phase
thing.
difference should be constant. Okay, and the light sources. Okay, that should be coherent in nature. Constant or zero phase difference. Okay, then the sources should be coherent. So if two sources satisfies this condition, then interference takes place. Interference means the word, you don't forget this word, that superposition. Superposition of two or more waves, they are having constant phase difference or zero phase difference. Two or more coherent waves with a constant phase difference or a zero phase difference, okay, undergoes superposition and forms alternate bright and dark fringes. Okay, such phenomenon we call it as interference. Okay, so interference is the basic or a phenomenon for the formation of Newton's rings. Okay, so Newton's rings, I mean sorry, इंटरफेरेंस चैप्टर खत्म हो गया क्या आप लोगों का?
चालू है.
क्या क्या हुआ है अभी तक? Okay, I mean, what are the portion? Sorry, क्या क्या हुआ है अभी तक? Who is your teacher actually? Prasad sir, right?
Yes, sir.
Okay. I think today only 2 members were getting attendance. No one is speaking in between. Please start talking in between. We want everyone's attention and everyone's comments here. Hello. Yeah, hello Aryan, बोलो. आप लोगों ने मैनुअल रीड किया था कि नहीं? हेलो.
हाँ सर, रीड किया है।
ओके, तो फिर आप बता सकते हैं ना.
सर जो मैक्सिमा और वो सब उसके सब फॉर्मूलेज करवाए थे।
हाँ, इंटरफेरेंस थ्रू थिन फिल्म्स के कर रहे थे
इंटरफेरेंस,
शायद.
यस सर।
यस, ओके.
फिर इंटरफेरेंस थ्रू वेजेस वो भी किया आज।
ओके, इंटरफेरेंस थ्रू वेजेस भी हो गया,
हाँ
इंटरफेरेंस थ्रू थिन फिल्म्स भी हो गया. ओके, वेरी गुड.
हाँ सर।
न्यूटन्स रिंग नहीं हुआ है ना अभी तक.
नहीं नहीं, वो नहीं हुआ।
फाइजाउस फ्रिंजेस एंड हाइडिंजर फ्रिंजेस. एंड हाइडिंजर फ्रिंजेस हुआ क्या?
नहीं हुआ है शायद।
नहीं ना.
नहीं हुआ
ओके.
ये, नहीं हुआ।
ओके, सो इसके बाद जो एप्लीकेशंस ऑफ इंटरफेरेंस आ जाएगा वहां पे न्यूटन्स रिंग के बारे में थ्योरी आ जाता है. ओके. ओके, then for me it's better to go with the practical sessions because मैं थ्योरी ज्यादा नहीं बोलूंगा, मतलब जो रिक्वायर्ड है इस लैब के लिए वही बात करूंगा. So we will have a general discussion on whatever we learned till today. Okay. Okay, अगर आपको कहीं कहीं बीच बीच में प्रॉब्लम आ रहे है तो अगर पता नहीं चल रहा तो मुझसे डिस्कशन कीजिए. लेट मी ओपन द मैनुअल फर्स्ट. Okay, I'm not going in detail with what is interference and all and other things. I'll just jump into Newton's rings. Okay. uh, so first I would like to introduce two types of fringes here. Okay, that is Faizaus. Whenever two beams. Okay, so it undergoes interference. When it undergoes interference like this, okay, it produces alternate bright and dark fringes. Okay, on the screen. Okay, these kind of fringes on the screen. Okay, so we need two sources. They are coherent to, they should be coherent in nature, and there should be some constant phase and path difference. Okay, superposition means mixing of two waves. Okay, so we have learned this, the resultant y is equal to y1 plus y2 and all those mathematics you did in your theory lectures. I'm not going in detail with the derivations. So there are two types of fringes actually. Okay, the first one here is Faizaus fringes. Okay, in Fizeau's fringes, okay, it is something like a wedge-shaped film. Here T varies. Thickness of the glass plate or thickness of the air film varies here. Okay, the R that remains constant. Okay, so here R constant, P varies here, like a wedge-shaped film. And in Heidinger fringes, okay, that is formed, alternate bright and dark fringes were formed. Their T remains same. The thickness of the film that remains constant. Okay, but R varies. R will look like this. Okay, here R varies. So these are the two types of fringes here. So how Newton's rings were formed? That is also, I mean, very interesting point here. So that uh, one can easily understand. Before that, before going to that, let me explain the Newton's ring Newton's ring apparatus. It is also called as Newton's ring interferometer. Newton's ring interferometer. So do you know about interferometers? What is interferometer? Hello? Hello? What do you mean by interferometer? Okay. Okay, Amay. Very good. Interferometer means it is a device. Actually, meter means device, right? So here, I mean, there are two parts, interfero and meter. Meter means here device. Okay, so device, which it's a device used to measure something. Okay, so that device meter, I mean, that can be, I mean, the meter can be a voltmeter. So it is used to measure voltage. That can be current meter used to measure current. Okay, that is meter device. Interfero means that meter uses, this meter uses interference phenomenon to measure something. Okay, that uses interference phenomenon to measure something. Such meters we call it as interferometers. Right?
Okay, sir.
Interferometers पता चला. Okay, so there are different types of interferometers are there. Michelson's interferometer. Okay, Fabry-Perot interferometers. Okay, and Newton's ring interferometers, etc. So this interferometer is constructed by, constructed using Newton's ring setup. That's why, I mean, we call it as a Newton's ring interferometer. So this device is used to measure refractive index of the medium. Okay, any medium. It may be liquid. Okay, it may be gaseous medium. Okay, and then you can use this to find out the radius of curvature. Radius of curvature of any spherical surfaces. Spherical surfaces. Okay, that's why, I mean, there is certain measurement that, I mean, we are going to do with the help of Newton's ring apparatus. That's why, and Newton's ring apparatus uses interference phenomenon to measure all these stuffs. Okay, so therefore this setup we call it as Newton's ring interferometer. Okay, we have to remember this because Viva was में question आ सकता है. The next part here is, okay, the next part here is, what is the physical significance of this experiment actually? Okay, one should know about the physical significance also. Okay. So the first significance is it is used as it is an interferometer. Okay, it is an interferometer. Okay, because it forms a steady state, a well-defined interference pattern. Okay, then it has many applications actually. The applications like uh, if you want to find out the refractive index of kerosene, okay, using this instrument you can easily find out or calculate refractive index of kerosene. Okay, then if you want to measure the what's that, uh, if you want to measure something like something called uh, uh, refractive index of some potassium bromide, or if you want to measure the refractive index of potassium iodide, or if you want to measure the refractive index of some crystals, okay, all that time you can use this setup. Okay, easily you can measure all those things. Okay, so that's what I mean, we call it as the measurement is precise and accurate, precise and accurate here. So that is the beauty of this experiment actually. Okay, and if you want to use, I mean, it can be used to test the uh, I mean, if you want to measure the thickness of some thin sheets, metal sheets, that also can be done with the help of this I mean interferometers. Okay, why you have to learn this, I mean why you have to do this experiment? Because it has many engineering applications also. Okay, in engineering also, in engineering field also, it is used. For example, uh, thickness measurement of uh, in thickness measurement of thin metal sheets. Okay, so industrial measurements जो रहता है ना वहाँ पे use करते हैं, and then it can be used to measure the refractive index of the some engineering fluids. I mean refractive index of engineered fluid. So that means there are some fluids, okay, transparent or semi-transparent fluids are will be there that you are going to use in mechanical gadgets or stuffs. So there, I mean, you can use this setup. Okay, so that is the physical significance and the application advantages of the Newton's ring apparatus. Okay, then the next point here is uh, 1 minute. Let me have some water. Okay, then what are Newton's rings actually? How they are formed? Okay, so Newton's rings are nothing but a concentric rings actually. They are circular fringes of alternate bright and dark fringes. Okay, so at the center it may be dark. Okay, then it will have a bright rings uh, with a different radius. Okay, these are, I mean, circular concentric rings which are obtained using I mean, some circularly wedge-shaped films. wedge shaped films. Okay, for example, okay, so it requires, I mean, how we will do the experiment, I mean, the setup will look like this. So we need a glass plate over here. Sorry, 1 minute. Huh? We need a glass plate. Okay, this is our glass plate actually. Okay, it will have certain thickness over here. This is our glass plate. So above which, above which, okay, above which a plano convex lens is placed. Above which a plano convex lens is placed. Okay, plano convex lens means आपको convex and convex पता है ना? This is cave. Okay, that's why it is concave. From here it is convex. Okay, just don't forget cave. If you remember cave, then I mean concave and convex, that confusion will not be there. Okay. So when a monochromatic light, okay, which falls on this material or this plano convex lens, okay, when you place a plano convex lens on a thin glass plate, what happens? Then there will be a gap, right, between upper surface and the lower surface, right? So it will look like this. Okay, then there will be a gap between the upper surface and the lower surface, right? So that gap is filled by some air. Okay, therefore this gap we call it as thin film, thin air film. Is it clear? Hello.
Yes, sir.
Yes, sir.
Okay, so thin air film is formed here. Okay, so when a ray of light which falls on it, I mean parallel rays which falls on I mean on this surface, okay, at this edge, it undergoes some sort of refraction. Okay, it will undergo some sort of refraction here. Okay, so along with refraction, so it will undergo reflection also. Okay, let me draw it in another part. So, and at this edge also it will undergo reflection. So these two rays undergoes, I mean, I'm sorry, it's very difficult to draw a plot here. Okay, I place a plano convex lens over here. Okay, this is the lens here we have placed. Then okay, so when a ray of light, which incident on this edge, okay, it will undergo reflection. Some part of it will undergo reflection, some part will undergo refraction. At the second edge, then there also it will undergo some reflection and some refraction. Okay, these two rays undergoes interference. These two reflected rays undergoes interference and forms alternate bright and dark circles, dark circular rings. Okay, so I mean what I'm going to tell you here is, so for, I mean there are two conditions, right? So one is phase difference. There should be some phase difference, constant phase difference. right? And sources should be coherent. We need two sources, and these two sources should be coherent. Okay, so light from some source. Okay, let us have a light. Okay, this is a single light which incident at this position. Okay, it is a single light which incident at this position as well as this position. Okay, so it reflects from this position as well as from this position. Okay, so the reflected rays are originated from the same source. That's why they are coherent only, right? These two rays are originated from this source. I mean, this beam, right? That means this is a coherent source. What about constant phase difference? There is a gap between these two emitted rays, reflected rays. Okay, so this is what we call it as phase difference. So that remains constant at this high, thickness. So when these two rays undergoes interference, okay, superposition, that will give us interference pattern. Okay, so this method of producing coherent sources, here the used method of producing coherent sources, we we call it as, it's a reflection method. It's a reflection method. Okay, one more is there. We call it as division of amplitude. Okay, in Young's double slit experiment. Okay, Young's double slit experiment, we divide the amplitudes here. A ray of light incidence on here, that divides the amplitudes, and that will undergo interference and forms the interference pattern. So here, uh, in the interference phenomenon occurred in sorry, in this experiment we use reflection method. Okay, reflection method to produce two coherent sources. theory क्लियर हो गया आपको, कैसे इंटरफेरेंस होता है और कैसे अल्टरनेट ब्राइट एंड डार्क फ्रिंजेस आता है, पता चला क्या? हेलो,
Yes, sir.
okay, now but here we are getting circular rings, we are not getting any alternate bright and dark fringes, linear rings. ऐसे linear rings नहीं मिल रहे हैं, हमें circular rings मिल रहे हैं ऐसे. What may be the reason for that? And the radius of each rings are different here. Okay, the radius of each rings are different. Why it is so? Why it is so? Reason क्या हो सकता है? Hello, hello.
Sir.
Yes,
Someone
sir.
please respond. Okay.
So,
Uh,
because the lens is convex, like
yeah.
symmetrical, therefore,
Okay.
so when it gets reflected back, it forms circles of equal radius.
Okay. Look at this diagram. Okay. What happened here is thickness varies here as you go away from the center to edge. अगर आप जा रहे हैं तो thickness increases, right? Thickness increases here. So ultimately क्या हो गया at this point, if you compare two nearby points, that path difference is different, right? So depending on path difference value, we will get alternate bright and dark fringes. But but the thing is that this, I mean, at this point, okay, if you plot a locus of points, so that is circular in shape. This thickness is circular in shape. Okay, here, I mean, just imagine in 3D picture, you are placing a concave lens on a thin glass plate. So the thickness here is equal to thickness here. Okay, thickness here is equal to thickness here. Thank you. Okay, that's why in this circle, actually, in this circle, okay, in this circle, the thickness remains same. If thickness remains same, in this circle, the path difference also remains same. Okay, so because of that, depending on that, okay, so we will get bright ring or a dark ring. Is it clear? Hello?
Yes, sir.
Okay. Okay, so that's why, I mean, we are getting circular rings at the I mean, Newton's ring apparatus. Okay, so here, I mean, I have answered some questions like I defined interference. Sorry, we defined interference. Okay, then condition for interference, then interference, condition for interference, then interference हो गया, condition for interference हो गया, and then we have discussed about uh, types of fringes. Okay, we discussed about types of fringes. Then we discussed about interferometers. 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 Then we discussed about uh, uh, I mean, types of producing coherent sources. Types of producing coherent sources. Okay, and we discussed about, okay, I mean, why rings are circular, why rings are circular in shape. Okay, why rings are circular in shape. Okay, we discussed about all these steps. Okay, so here, let me next go and let me draw experimental setup here. Okay, so we will have a source of light over here. So we will have a source of light. Okay, from here light will be emitted out. Okay, so actually if we have a source, then there will be a, I mean, diverging beams, right? Is it right? Hello?
So can you repeat?
I mean, when light is emitting out from a source, okay, how it will look like? Whether it will, I mean, it will look like, I mean, how the light rays are emitted out from any source? Is it a diverging beams or a parallel beams? Parallel beams means
Diverging.
it will, yeah, it will diverging beams, right? But we need a parallel beams. Then what we can do? We have to make these beams parallel. Okay, after some time, it should go like this. So how one can do this? Anybody, please? Hello? Hello? Hello, hello. Am I audible or not?
Yes, sir.
Hello, sir.
Hello. How one can make this diverging beams into parallel beams? Any
So we
idea?
can place some plates in between so that it gets.
Yeah. What kind of plates? Yeah, very good. What kind of plates?
So small holes, like very small, tiny holes.
Yeah. If it is tiny, then also there will be a divergence. So we have to place something here. I mean हम क्या यहाँ पे सेट कर सकते हैं?
Convex lens.
Very good, very good. There are different types of lenses are there. Okay, concave lens and convex lens. So we have to place a concave lens here. Just place a concave lens. Okay, so the role of concave lens is to the emit out parallel beams. Okay, यहाँ से parallel beams आपको बाहर आ रही होगी. So now what I have to make? My setup is here. Okay, my setup is here. So I need a glass plate. Okay, this is my glass plate. It should be leveled. Okay, मेरा थोड़ा क्रॉस चल रहा है क्योंकि मेरा ड्राइंग उतना अच्छा है यहाँ पे. So then we have to place a planar convex lens over here. Okay, so here I mean it's a wedge shaped film. Thickness is varying here. Okay, so I mean parallel beam should fall on this. So उसके लिए हम क्या कर सकते हैं? So what I will do here is I place a semi-silvered glass plate. Okay, it is a semi-silvered glass plate. Okay, semi-silvered glass plate it is. Okay, so when these rays that will incident on this, when these rays will is incident on this, so it will reflect back, okay, on this. I mean, it should be straight line. I'm sorry, but I'm unable to draw the straight line over here. Okay, I mean, let me draw a straight line using this. Okay, it will be like this. Okay, and along with that, some of the here some part will be reflected back also. Okay, so let me have an arrow mark to show you clearly. So this is your incident beam. Okay, so on this semi transparent plate. Okay, semi transparent means so it undergoes reflection as well as refraction also. Some of the rays will refracted through this uh, semi transparent glass, I mean glass plate, and some of them will be reflected. Okay, 90-degree. So here like this. Okay, this reflected rays that will undergo reflection and refraction at these positions. Okay, at these positions. So and it will reflect back. Okay, these reflected beams from lower and upper edge of this thin air film. Okay, thin air film undergoes interference and that will form a circular rings like this. Okay, we will see, I mean, circular rings like this. I will show you video also. Okay, I'll share the video link also after this explanation. So it should be circular. Okay, so circular rings like this. Okay, so this is how, I mean, Newton's rings were formed. Then how to say these Newton's rings? Okay, for that we have to place a traveling microscope over here. Okay, we have to place a microscope. Okay, we place a microscope. So through that microscope, one can see these rings, and one can make the measurements also. Okay, this is what the experimental setup for Newton's ring experiment. Okay, this is the experimental setup. We need a monochromatic source like a sodium source. Okay, sodium source का कलर क्या रहता है, पता है क्या किसी को? हेलो,
So can you repeat?
No,
सोडियम सोर्स का कलर क्या रहता है? What is the color of sodium source? हेलो,
Sir, yellow.
या सोडियम सोर्स का कलर येलो रहता है. Okay, so that's why it's a monochromatic source actually. I mean, what do you mean by monochromatic?
So light having a single color.
Yeah, it is having single color, or wavelengths are very nearby with each other. Okay, so the difference between the wavelength is nearly equal to 0. Okay, such sources we call it as monochromatic sources. Okay, even though sodium which is having doublets, which emits two colors, both are yellow itself. Okay, the difference between two wavelengths are 6 angstrom. Okay, that's why we use sodium source here. Okay, yellow in color it is. So, and we use some convex lens here, convex lens. So in order to make the rays parallel, okay, because this is the case of Fizeau's fringes, okay, in which the thickness, in Fizeau's fringes kya hota hai? It will look like this. This thickness varies, T varies, and then R remains constant. Okay, T varies and R constant here. T varies and R constant here. So that's the case of Fizeau's fringes. So in order to keep R constant, so what we have to do, we have to use some plano convex lens here. Sorry, convex lens here. So the light coming out from a convex lens, that will be parallel beams. So what we have to we have to make it fall on the our plano convex lens setup, Newton's ring setup. Actually, this is the setup. Okay, so for that we use semi-transparent uh, glass plate. Okay, semi-transparent glass plate it is. Semi-transparent glass plate. Okay, it is inclined at an angle of around 45 degree. It is inclined at an angle of 45 degree. Okay, so that we will get 90-degree reflection here. Okay, so this reflection, angle of reflection is 90 degree here. Okay, so reflected rays undergoes reflection and refraction phenomenon at the edges of the thin air film. Okay, those rays undergoes superposition and forms the circular alternate bright and dark fringes. Okay, that can be viewed from microscope. Actually, we call it as traveling microscope. Okay, just because along x-axis and y-axis, so along x-axis and y-axis, we are going to change, we can move the microscope position. Okay, that's why we call it as traveling microscope. So is it clear? Experimental setup के बारे में पता चला ना आपको कैसे करते हैं?
Yes, sir.
Yes, sir.
Okay, good. What about others? Please put your remarks in chat box also. Lana Rhodes. Lana Rhodes, can you see our whiteboard here? I mean, okay, I mean, my display is visible. I mean, whiteboard is visible, right?
Yes, sir.
Okay, fine. Uh, okay, this is what about experimental set. Okay, then what we are going to, I mean, how to measure the readings. So we understood here till now. I mean, the formation of rings we discussed. I mean, we discussed about formation of rings. Okay, till now, formation of rings we discussed. Okay, we discussed about formation of rings, and we discussed about uh, what's that? Uh, experimental setup here. Experimental setup. Okay, now I mean we have to discuss about how to take the readings. Okay, that's a very important part here. Okay, I'll share the video. I mean later, so there you can go and watch how to take the readings and how to make the setup. Everything is there in that particular, and this theory is also explained very well in that particular video. Okay, later I'll share that video. Okay, now I will explain 1 minute. Okay, so what we can do it here, how to take the readings over it. Okay, so once uh, I mean agar aap, I mean if you look at the uh, traveling, I mean if you are watching that rings through traveling microscope, the rings will look like this. Okay, I'll try to draw it, uh, I mean in circle. uh, don't laugh at it. So this is our first ring, second ring, third ring, and fourth ring, and fifth ring, and so on. Okay, there are infinite numbers of rings are formed here. Okay, that will form here. So now how to take readings. Okay, when you look at the traveling, I mean, is anyone knows about microscopes, traveling, or any microscopes you guys used?
Sir, I've used traveling microscope.
Yeah, that means you are all aware of traveling microscope, right?
Yes, sir.
Fine. So initially you have to calculate least count of the traveling microscope, right?
Yes, sir.
Then if it is a Vernier scale, then you have to calculate total reading.
Least count.
Yeah, total reading is equal to formula MSR plus coinciding Vernier division into least count is the formula. Okay, I mean bracket it is. That means you have to multiply this, then one should have to add MSR reading. Okay. Uh, okay. Then I mean I will tell you how to take MSR readings and CVD least count. So if you look at traveling, I'm sorry, if you look at the Vernier caliper, okay, there will be two scales, right? Uh, like this. and one more scale is that will be above here. Okay, that will have a, I mean, some other divisions like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. ऐसे divisions रहते, 10 भी रहते, 50 भी रहते, something. Okay. So this scale we call it as, I mean, the above scale is movable. Okay, this is movable scale. This is static scale. That static scale we call it as main scale. Okay, static scale जो रहता है that is main scale. This scale we call it as vernier scale. याद है क्या वर्नियर स्केल और मेन स्केल आप लोगों को? So MSR means main
Main
scale
scale
reading.
reading.
Yeah, main scale reading, and VSR or CVD. CVD means
Vernier scale.
yeah, coinciding vernier scale division. Vernier scale division. Coinciding vernier scale division. Okay, so then how to take MSR and CVD readings? Okay, so for example, okay, here is a scale. Okay, now this is our 0th line. Okay, this is our 10th line. This is our 0th line. So I mean, it will be something like this. Okay, and here something, here 2 is there, it is 3, it is 4, 5, and so on. Okay, so 0th line is around here. 0th line is around here, because I mean इसके पीछे है. I mean 2 के बाद 2.1, 2, 3, 4, 5. 2.5 के नीचे है 0th line, right? So that means MSR is how much here? MSR is equal to 2.4 centimeter, right? Hello. So this is our first line in the vernier scale. That first line is behind this 2.5. So in our scale, this is 2 and this is 3, right? So MSR is how much? Behind this 2.5 line. So therefore 2.4 centimeter is the MSR. Okay. In this 10 divisions, any one line, okay, कोई एक line क्या हो सकता है? That will be in coinciding with the main scale division. I don't know whether it is coinciding. Yeah, let us consider this coincide with this line. Okay, let me erase first. Okay, uh, let me take a straight line. So I'll draw a straight line over here. Okay, here, look at here. So this line, okay, it is coinciding with the one of the main scale division. Only one line that will coincide with the main scale division. Okay, the number of that coinciding line we have to calculate. So this is 0, उसके बाद 1, 2, 3, 4, 5, 6. So sixth line is coinciding. Therefore CVD, which is 6 here. पता चला आपको? There is no unit. Okay. Then total reading. How to calculate MSR? MSR means 2.4 centimeter. Okay. Plus in the bracket CVD, that is 6. Okay. Then least count we have to calculate. So least count is equal to what? Least count का formula क्या है? Hello anyone? Least count का I mean sorry formula है क्या है? Least count LC is equal to S divided by N. पता है क्या आपको? याद है क्या? Value of हाँ बोलो. Value of smallest division of main
Smallest
scale.
reading.
Upon
Okay,
number.
smallest
Yes, sir.
yeah, smallest division on main scale, okay, upon total number of divisions on
Vernier
or
scale.
Vernier scale. Value of smallest division on main scale divided by total number of divisions on Vernier scale. So यहाँ पर कितना है value of smallest division on main scale? 2 to 3. In between there are 10 divisions. So each division का value कितना हुआ in centimeter? I mean in 1 centimeter there are 10 divisions. Okay, 1 centimeter divided by 10 whole divided by the total number of Vernier scale divisions. कितना है 1 2 3 4 5 6 7 8 9 10, right? 10. So this is equal to how much? कितना है ये? 0.01 centimeter per
01.
divisions. Yeah,
Yes, sir.
0.01 centimeter per division. So just multiply this with this 0. अरे बाप रे क्या हुआ? 0.1. Okay, just solve this. So पहले just multiply with this, okay, and then add this. So TR, which is equal to how much? 2.46 centimeter, right? Right? Hello.
Hello, sir.
Hello,
So
is
can
it
you
right?
tell, so can you tell how to calculate that main scale reading? Once again.
Yeah, okay. Main scale reading, right? So this is our 0th line on the Vernier scale, right? जो starting का जो line रहता है ना, that is 0th line. Okay. So if I mean that line, so वो line क्या हो जाता है? Main scale पे एक reading दिखाता है. Okay, that will show some readings on the main scale. I mean, let me redraw it again. Okay. So this is our Vernier scales. Sorry, it's our Vernier caliper. So this is our this is our main scale. This is 2 and 3. बीच का 2.5 है. Okay, and this is our main scale. Sorry, Vernier scale. 0 1 2 3 4 5 6 7 8 9 10. There are 10 lines. This is 0 and this is 10. Okay, so we have to calculate MSD here. So for that what we can do, okay, so this 0th line, okay, let me draw a straight line over here. Okay, this 0th line I mean shows some readings over here. Is it right? Okay, so that line is in between 2.4 and 2.5, right? Right, this line is in between 2.4 and 2.5, so that is MSD 2.5. Is it clear?
Yes, sir.
Okay, and CVD we have to calculate VSD or CVD, both are same, which is equal to. So let me take one more straight line. Okay, मैं क्या करता हूँ, एक straight line draw करता हूँ यहाँ पे. देखो, I mean it is matching with, okay, this line is matching with the main scale reading. There are two lines. One I mean the both the I mean Vernier scale का एक line and main scale का एक line. Okay, these two lines they are coinciding with each other. Okay, अगर बाकी सब I mean किसी भी line को select करो वो match नहीं हो रहा है. Okay, if you draw this versus this, that will be I mean थोड़ा आगे पीछे हो जाएगी. Okay, that means this second division of this Vernier scale. Okay, so this is the what? VSD. Okay, so VSD is how much? 0 1 2. Okay, second division is matching with the VSD. Okay, least count that is given by S divided by N. So S means value of smallest division on the main scale. There are in 1 centimeter, there are 10 divisions. So 1 centimeter divided by 10, whole divided by there are 10 divisions on the vernier scale. So 10, that is nothing but a 0.01 centimeter. Okay, now total reading, which is equal to formula क्या है हमारे पास? Okay, so formula is something MSR plus CVD into least count. So don't forget to put bracket here. Okay, because we have to finish this term, I mean this calculation first. Okay, then we have to add this. That is second. Okay, so MSR is how much? That is 2.5 centimeter plus CVD is how much? Okay, CVD is 2 here and least count 0.01 centimeter. Okay, so bracket it is. So this is equal to 2.5 plus 0.02 centimeter, which is equal to 2.52. पता चला आपको? Hello?
Yes, sir.
Okay, then let me go back. Okay, हमें ऐसा रिंग मिला है अभी, रीडिंग्स लेना है हमें. Okay, so आप लोगों ने टैबुलर कॉलम ड्रॉ किया है ना? आपके पास टैबुलर कॉलम है ना? Okay. Let me draw a tabular column over here. Okay. So number of the ring will be here. So upper position, that is P, lower position, that is Q, or left or right position Q. Then diameter D M, which is equal to P minus Q. Okay. Then dm square. Okay, this is what we are going to calculate here. Okay, so let me go back. So this is our setup. I mean rings which we have already set here. Okay, and आप सबको पता रहेगा कि जब आप माइक्रोस्कोप से देखेंगे, ओके, ट्रैवलिंग माइक्रोस्कोप से देखेंगे, सो क्या हो जाता है, ए आपका आईपीस है, याद है ना आपको? आप लोग डू यू गाइस रिमेंबर दिस थिंग्स? हेलो? eyepiece, in between the eyepiece there will be a cross wire. ऐसा था कि नहीं? हेलो हेलो, kindly unmute yourself and talk, okay? Because yes, okay, fine. So हमें क्या करना है, and we have to adjust the screws. Okay, I'll show you. I'll show you in simulation that I'll come back to later simulation. So if you want to measure, let us take, this is our first ring, second ring, third ring, fourth and fifth ring. Let me take fourth ring's diameter. I want to measure the fourth ring, diameter of the fourth ring. What I will do, I'll focus the crosswire here. Okay, I'll focus the crosswire here. Okay, and I collect the readings from here, MSR and CVD. Okay, and similarly at the fourth ring, at this position. Okay, I'll collect Excuse me, sorry. Okay, I'll focus at the same ring, a lower position. Okay, there also I collect MSR and CVD. Okay, initially, so at I mean how to take the calculate the diameter of this fourth ring. Diameter means what? Distance between from here to here, right? Okay, distance from here to here is the diameter. Okay, this is diameter actually. Okay, I have to measure the diameter. So for that, I focus cross wire over here and cross wire over here, right? I'll focus cross wire over here and cross wire here. So क्रॉस वायर जब यहाँ पे होगा देन आई विल कलेक्ट एमएसआर एंड सीवीडी. जब यहाँ पे होगा आई विल कलेक्ट एमएसआर एंड सीवीडी. Okay, from total readings, okay, I'll collect a P value from this region and Q value from this region. Okay, so I'll note down those values here. So for ring number 4, P, if it comes around 2.26, Q 3.51, मुझे पता नहीं मैं ये कर रहा हूँ. Then calculate the difference between these two. It will give us diameter of the wire and square it. Okay, similarly we have to do it for all the rings from 5, 4, 3, 2, 1. Okay, हमें dm square मिल जाएगा. Okay, उसके बाद हमें क्या करना है? We have to plot a graph here. Okay, dm square or d square, diameter square versus ring number 1, 2, 3, 4 and 5. Okay, and diameter is something like this. So we will get inclined straight line over here. So you have to calculate slope over here. A, B, C. Slope is equal to AB divided by BC. Then using a formula. Okay, then using the formula, that is R, which is equal to 1 into slope. Okay, that is given in your manual, divided by 4 into lambda. Okay, so lambda, I'll share the value of lambda here. I don't know whether it is given here or not. Okay, lambda is 5890. 5890 into 10 to the power minus 8 centimeter. Okay, 5890 angstrom it is. Just substitute here and substitute slope value. That will give you radius of curvature. Okay, after that you have to calculate error. So in manual there is a formula for error calculation also. So that is percentage deviation. Okay, percentage deviation, which is equal to RS minus RE divided by RS into 100. So it is mod. Okay, it is mod. So RE means the value which you obtained from this calculation. Okay, experimental radius of curvature, RE. Experimental radius of curvature. Radius of curvature. Okay, RS means standard radius of curvature. Standard radius of curvature. So then you have to calculate percentage of deviation. After that, what you have to do, your understanding or my understanding about the experiment we have to write. About experiment we have to write and we have to make the submissions. Okay, is it clear how to do this experiment and all those steps? Hello?
Yes, sir.
Okay. Sorry. If
So
it is
can
so,
you
then
repeat? So what we have to do,
okay,
can you repeat?
okay. Then okay, I will share the details again. I mean, once again while doing simulations. Okay. So the thing is that the submission procedure is something like this. Write down the title. That is very important. Date, title. Actually, sorry. Title of the experiment, date, name, okay, your PRN number. Okay, that you have to write down. Then this observation you just write down. Observation, that is finding least count. The tabular column is there in the manual. Then this tabular column you have to write down. Then plot the graph. Then do the calculations. Okay. Then you just write down, do the calculation. You just write down your understanding about the experiment and make the submission. That's it. Okay.
So like we have to do it in a practical notebook or any notebook, like is it?
Any notebook, no problem. Any notebook. Okay. Any notebook, but submission should be in one page. That too today only. Okay. Is it okay? So shall I share the next part? Uh,
So can you repeat where we have to submit it?
okay, I'll share with you. Okay.
In the group, main group?
Uh, no. I'll create a Google Drive for you all. Okay.
Oh, okay, sir. Thank you.
Okay. I will share the simulation link in 2-3 minutes. Before that, I'll explain you how to perform. I mean, how to use that simulation first. Okay. Uh, yeah, it is here. Is it visible screen?
Yes, sir.
Okay. This is our, I mean, Newton's ring setup actually. Okay. Yeah. So look at here. I mean, this is traveling microscope. Okay. Here we have a um, uh, that apparatus, concave lens, as well as thin glass plate. Okay. I mean, here it is, below which that glass plate is set here, but it is not visible clearly here. So this is our traveling microscope. Okay. I mean, this complete setup is our traveling microscope. Horizontal vernier and vertical vernier is here. This is vertical vernier. This is horizontal vernier. So we are going to take readings only on horizontal vernier. Okay. Here, this is our main scale. This is our main scale. Okay. This is our vernier scale. This is our vernier scale and this is our main scale. Is it clear? Hello.
Yes, sir.
Now you have to calculate least count of this scale. Just calculate least count. Everyone, please do it fast. Least count कैसे निकालना है मैंने बताया आपको, लेकिन now you have to do. How much it is? Least count. Hello. Is it visible or not?
Yes, sir, it's
Yes, sir,
visible.
it is visible.
Okay. So I will do one thing. I'll explain first. Later, I'll share the link. So at that time, you just calculate the least count and do the experiment. Is it
So,
okay?
so is it 0.52?
No. How? The value of smallest division कितना है यहाँ पे? 3 to 4. There are how many divisions are there in between 3 and 4? Count it. 0,
So
1,
20.
2. Yeah, there are 20 divisions, right? 3 to 4 means 1 centimeter. 1 centimeter, in 1 centimeter, there are 20
Sir,
divisions.
1 divided by 20.
Yeah, 1 divided by 20 is S here, right? Then how many divisions are there in Vernier scale?
10.
No, count it here. From 0 to 0.5, how many divisions are there?
So 0
Each
to
0, 0.5. From here to here, total number of divisions. Yes.
it is 50.
Yeah, it is 50. So formula is simple, S divided by N. That is 1 divided by 20 divided by 50. How much it
So
is?
50 divided by 20, 2.5.
No, 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 no. 1 divided by 20 divided by 50.
Wha- Uh, 1 divided by 1
I mean,
divided
it is
by
something
1000.
like this. Yeah, 1 divided by 20. That is S, right? And N is equal to 50 it is. 1 divided by 20 is how much? 0.5?
0.
Yeah, LC is equal to 0.5 divided by 50.
Sir, it's 0.05.
No,
1
0.5 divided
divided
by
by
50.
No, sir, 1 divided
0,
by 20 is 0.05.
yeah, 0.05. Okay, in centimeter, right?
Yes.
Is it 0.05?
So the answer is 0.001.
Yeah, 0.51, 1.52, 2.53, 3.54. Yeah, right. You are right. 0. Least count is equal to how much? 0.5, sorry, 0.05 divided by 50. 0.001 centimeter per division, right? So this is the least count. पता चला ना आपको least count find out करना? So there may be a circular scale रहेगा, नहीं तो कुछ भी, I mean, there are different types of scale will be there, but this is the, I mean, simple method to find out least count of any instrument. I mean, any instrument like Vernier caliper. Okay. पता चला ना आपको? Hello.
Yes, sir.
Okay.
Yes, sir.
So this is what our, I mean, least count we have calculated actually. So I mean, here is a tab. Okay, इसको यूज करके आप लेफ्ट राइट मूव कर सकते हो. ऊपर नीचे मूव करने के लिए यहाँ पे इसको रोटेटर यूज कर सकते हो. Okay, so I mean, I'll show you. So आपको इमेज, here is a eyepiece. Okay, so इस eyepiece पे आपको इमेज दिखेगा, रिंग्स फॉर्म हुआ हो गया तो वो दिखेगा. So medium of the thin film. Okay, that is air. Okay, we are not filling anything else. So you can fill water here, you can fill acetone, anything. Okay, now I'll start with experiment air only. Then so light source, neon use कर सकते हैं, green light use कर सकते हैं, red light use कर सकते हैं, कुछ भी use कर सकते हैं, but I'll use sodium. Okay,
So
so let
mostly
me
sodium.
हाँ, yeah. So now let me switch on the instrument. Light on कर दिया मैंने, देखो. Okay, light on कर दिया. but you can also change the radius of the lens. Now it is 50. Now I'll make it 100, 70 or this. Okay, I'll make it 70. Okay, so मैंने 70 कर दिया यहाँ पे. 70 करने से क्या हो जाता है? That the standard radius, okay, that is 70 here. आप कितना भी रख सकते हैं, 50 to 100 कितना भी रख सकते हैं. Okay, you can keep it as 100 also. Okay, आप कितना भी रख सकते हैं यहाँ पे. Okay, then whether it is clear or not, आपको यहाँ पे एडजस्ट कर सकते हैं रोटेट करके. सो माइक्रोस्कोप फोकस यहाँ पे वेरी हो रहा है, सो लेकिन वहां पे कुछ मत करो, यहाँ पे सेट करो दिस टैब. क्लियर? आई मीन इज इट क्लियर? सो इट शुड बी क्लियर, राइट? देखो यहाँ पे डिस्टर्ब होता है, सो डिस्टर्ब नहीं होना चाहिए. दैट शुड बी एज शार्प एज पॉसिबल. ओके, अभी तक जो किया वो पता चला ना आपको? हेलो?
Yes, sir.
Yes,
Okay.
sir.
Then I mean there are lot many rings are there. Okay, so if you want to check, I mean here is a crosswire. This is our crosswire. Crosswire is visible, right? Right?
Yeah.
Hello. Okay, so next what I will do here, so I'll rotate I mean I'll move this crosswire to our, I mean हमें 5 रिंग का डायमीटर निकालना है, 1 2 3 4 5, in order to take readings, I mean plot a graph. So I'll move this left or right side. So I'm using this knob to move. I'll move it to right hand side first, sorry, left side first. This is our first ring, second ring, third ring, fourth and fifth. मैंने फिफ्थ रिंग के ऊपर फोकस कर दिया है यहाँ पे. टेक MSR and CVD. ओके, पता चल रहा है ना? You have to take MSR and CVD at this point. Okay, so MSR is something here, 2.4, 2.3 here. Okay, CVD is something around this one. I mean, for me it is clear, right? 5. Okay, 2.3 and 5 is the MSR and CVD. So by substituting in formulae, we will get the P region. Okay, for a fifth ring. Okay, that we have to enter in the P. उसके बाद मैं क्या करता हूँ, फोर्थ रिंग के ऊपर फोकस करता हूँ. ओके, फोर्थ रिंग का लेता हूँ, लेफ्ट साइड का ही फोर्थ रिंग, उसके बाद लेफ्ट साइड का ही थर्ड रिंग, उसके बाद लेफ्ट साइड का ही सेकंड रिंग, लेफ्ट साइड का ही फर्स्ट रिंग. सो आई विल मूव इट इन द सेम डायरेक्शन देन. ओके, बाद में मुझे क्यू पोजीशन ऑफ फर्स्ट रिंग पहला मिलता है. ओके, आई विल टेक PSR एंड CVD हियर, and then PSR and CVD here for second ring, then PSR and CVD for third ring, and PSR and CVD for fourth ring, PSR and CVD for fifth ring. वो सब होने के बाद, okay, so I'll enter all those readings in my, okay, in my tabular column. Where is that? Okay, मुझे क्या मिलता है? फिफ्थ रिंग का पहला P वैल्यू मिलता है. Then here 2.21 समथिंग, ये मैं रफ वैल्यूज लिख रहा हूँ. थर्ड पोजीशन, ओके, ऐसे मिल जाता है. उसके बाद हमें यहाँ पे मिलता है 1, 1.5, आई मीन समथिंग हियर, समथिंग हियर, समथिंग हियर एंड समथिंग हियर. ओके, पहले ऐसे चलता है रीडिंग्स, देन इधर से ऊपर जाता है. पता चला आपको? Is it clear? Initially you have to focus on fifth ring. Okay, then fourth ring you have to take reading, third ring, second reading and first ring. Then from first ring, second ring, third ring, fourth ring and fifth ring, ऐसे रीडिंग लेना है आपको. पता चला क्या? हेलो?
Yes, sir.
Yes, sir.
Okay, then difference between these two you just calculate. Then dm square, whatever the diameter you are getting, square it, plot a graph d square versus n. Then you just calculate the slope. Okay, I mean draw a triangle at any position of that particular graph. So that will give us, I mean, mention A, B, C points, calculate AB distance and BC distance. That will give you slope. Then use this formula RE is equal to 1 slope divided by 4 into lambda. So lambda here is 5890 into 10 to the minus 8 centimeter. Okay. So then what you have to do, percentage of deviation जो standard आपने रखा था ना simulation में, that radius of the lens, so that is standard. Okay, for in my case that is 75 centimeter. Your obtained radius of curvature, then solve this and then write down the result and write down your understanding about the experiment and submit. Is it clear? If it is clear, then I'll share the link of at the chat box of the simulation. अगर आपको कुछ क्वेश्चन है तो आप पूछ सकते हैं बीच में. हेलो.
No.
Hello, Manan. Pardon, please. Hello. Once you finish this, I'll share the video link also. Okay. So, I mean, is this link available for you?
Yes, sir.
Okay. Everyone, please do the calculation and please take the reading and start doing calculations. Okay, I'll be here. Okay. Before 4:30, I mean, we have 1 more hours to go. So before 4:30, we have to complete everything and make the submissions. अगर आपके पास कुछ प्रॉब्लम है तो पहले ही बता दो.
हेलो सर।
हेलो हेलो।
सर वो रीडिंग्स लेने के लिए सर वो टेबल दिया था ना आपने, वो एक बार दिखाओ ना।
शेयर करना है ना मुझे। Wait a
हाँ
minute.
सर।
क्या कौन सा चाहिए था, ए क्या?
हाँ सर, यही है।
ओके ओके।
सर तो यही फॉर्मेट में लिख के आपको भेजना है क्या?
हाँ, आप ग्राफ शीट के पीछे एक सब कैलकुलेशन करो अगर पॉसिबल हो तो। देन जगह रहा तो योर अंडरस्टैंडिंग अबाउट द एक्सपेरिमेंट लिखो। और मैंने मैनुअल शेयर किया है ना, उसमें कैसे ग्राफ ड्रॉ कर रहे हो वो सब डिटेल्स में करके मुझे भेज दो, चलेगा ना?
ओके सर। सर प्रोसीजर नहीं लिखना है ना? हेलो सर।
हेलो।
सर अगर अभी ग्राफ पेपर नहीं है तो बाद में सबमिट कर सकते हैं क्या?
हाँ, कर सकते हैं। कैसे कर सब, आई मीन कैसे सबमिट करोगे आप सब?
सर आप ग्रुप बना सकते हो, फिर उस पे सब डाल सकते हैं, ऐसा कुछ।
ऐसा है क्या?
सर या फिर मैं ग्रुप बना देता और उसका जो इनवाइट है मैं चैट बॉक्स में डाल देता हूँ।
ओके, चलेगा। नहीं तो मुझे मेल कर दीजिए ना पूरा, चलेगा ना?
ठीक है सर।
हाँ, किसने ग्रुप, कौन, आई मीन कौन बनाने वाले हैं अभी?
सर आपकी मेल आईडी। सर मैं
मेरा
बना
मेल
रहा हूँ।
मेल आईडी में।
मेल ID।
ओके ओके, मेरा मेल आईडी चाहिए ना, चैट में डाल देता हूँ। jagdish.naik@mitwpu.edu.in. ओके, दिस इज माय ईमेल आईडी। ओके, सो मेल भी कर सकते हैं, अगर ग्रुप में डाल दिया तो ग्रुप पे भी डाल सकते हैं। ओके।
ओके सर।
ओके, देन इज देयर एनी क्वेश्चन? अब अगर व्हाट्सएप ग्रुप बना दिया तो अभी बना दो। मैं क्या करता हूँ, उसी ग्रुप में वीडियोस भी शेयर करता हूँ, ग्राफ, आई मीन प्रैक्टिकल रिलेटेड अगर कुछ वीडियोस हो तो मैं वो शेयर कर देता हूँ। ओके।
यस सर।
Sir, can you tell us that what's the title?
न्यूटन्स रिंग।
Okay, sir.
सर और प्रोसीजर नहीं लिखना ना?
प्रोसीजर नहीं लिखना है, मुझे सिर्फ
सर वो
ऑब्जर्वेशन, टैबुलर कॉलम, कैलकुलेशन, ग्राफ, एंड देन योर अंडरस्टैंडिंग अबाउट द एक्सपेरिमेंट लिखना है।
ओके सर।
ओके सर।
ओके। अगर किसी, आई मीन कोई लेकर नहीं आया क्या ग्राफ शीट?
सर अभी नहीं है, बट सर कल तक हो जाएगा। आप बताओ कब तक सबमिट करना है?
मुझे आज ही किया तो अच्छा लगता है।
So I've just sent the invite link in the chat
ओके,
box.
हियर इट इज, राइट। अभी सेंड किया है क्या आप लोगों ने? ईमेल पे है
Oh,
मुझे।
so, sorry. 1 minute, 1 minute.
हाँ, ओके। यस।
मिला लिंक सर?
So
हेलो।
got the link?
हाँ, या नाउ आई गॉट।
Okay, sir.
So, I mean, what next then?
सर विल सबमिट।
So within an hour
हाँ,
or like before 6 o'clock, you set a time limit, we'll submit it on the group.
okay, for me, no problem. But if you postpone these things now, then I mean, it will be heavier for you only. मुझे आज करो कल करो कुछ फर्क नहीं पड़ने वाला है। I mean, I don't bother about these things. So someone take care about that submission timing. Okay, आप लोग ही डिसाइड करो कि कब सबमिट करना है। ओके, लास्ट डेट आप लोग ही फिक्स करके ग्रुप में डाल दो, उसके अंदर सभी को सबमिट करना है। चलेगा क्या?
ओके सर।
ओके, आप लोग ही
ओके
डिसाइड
सर।
कर दो एक क्लास टाइम क्या रहना चाहिए, और आप लोगों को सबमिट करना है। अगर मैं गूगल ड्राइव में सबमिट करना है तो मैं गूगल ड्राइव लिंक शेयर कर दूंगा, मेरे पास है। आई मीन मैं क्रिएट करके शेयर कर दूंगा। यहाँ पर आई मीन करना है तो भी मैं बता दूंगा।
सर व्हाट्सएप ग्रुप पे ही कर दीजिए।
ओके, यहीं
हाँ
पे कर
सर,
दो। ओके
हाँ व्हाट्सएप पे कर देंगे।
ओके, इज देयर एनी डाउट रिलेटेड टू दैट एक्सपेरिमेंट?
Sir, we need to write in
हेलो, पार्डन प्लीज।
Sir, have you recorded this meeting?
या, आई रिकॉर्डेड दिस मीटिंग।
Will you upload this on YouTube?
Actually, not. I'll try to upload in YouTube, but I'll upload in Google Drive and I'll share the link. Is it okay?
okay sir,
Yeah, sir,
link
that
is
would be
okay sir.
great.
Okay,
So
that I
you
will
can
do.
share the link in the WhatsApp group and we'll submit
Yeah,
it by
definitely.
today only.
Okay, okay, no problem. Okay. So, shall we conclude then?
Yes
Sure,
sir.
sir.
Okay. Thank you. If
Thank you,
any
sir.
doubt is there, you just put me a message in the group. Okay.
Okay sir.
Okay.
Yes, sir.
Thank you.
Thank you, sir.
Thank you, sir. Bye, sir.
And sir,
Ha.
will you share this link on the group, the animation link, simulation link?
Okay. Now itself I'll
Yeah,
share. Okay. बाद
yeah.
में
Thank you, sir.
Okay. Thank you.
Okay, bye, sir.
Bye.
Bye, sir.
Bye. नहीं आ रहा है।